thank you for joining us. And you can hear from Ivor, who is a General Assistant at the Observatory Science Centre, which is an interactive educational and historical attraction located in East Sussex. Some of you may have been there already. It's great to see so many people joining us today, and to celebrate Mars Week, Ivor will share his story about his enthusiasm for planet Mars. Please feel free to ask any questions by putting them into the chat, and Ivor will aim to answer as many as he can at the end of his talk. So that's enough from me. I'll hand you over to Ivor. Good afternoon, Ivor.
Good afternoon to all of you there in the background. This is a personal journey or story, which started when I was 6 or 7, and I'll be 67 this month. So the maths there are quite interesting. I first started my enthusiasm for Mars with a ray gun and a sticky dart, which I used to fire at a target which had Mars as my main focus. So I've been fascinated by Mars and also by space since I was 6 or 7. I now work in space. I work at the Observatory Science Centre, and I work, excuse me, in a great space as well. So next slide, please. Telescopes. This is the first of 3 subjects for this afternoon. Telescopes, followed by tall stories, followed by true stories. Now, telescopes, as you know, are big, and astronomers, their favourite size of telescope is big. They also call them light buckets, because what a telescope is doing is getting as much light as it can get, so that the astronomer or the observer can either see more clearly a very distant object or enlarge something that's a bit closer. Now, here at the observatory, we have a number of historical telescopes, a number of which still function. So we have 2 modern ones, which are going to be, sorry, 2 old ones, which are going to be the focus of this talk, and a modern one. And it's all about working, of course, in space. So next slide, please. I've called this one Clarity, because what you can see there from a rather strange angle is a photograph I took recently of probably our most famous and most favourite telescope here at Herstmonceux, the Thomson telescope, which has a 26-inch lens, or it's called a refractor. Now, this was built back in 1896, and it's still going strong. And what you can see in the photograph is the underside of the telescope itself, which is a fair old length to allow for the best image possible, with the doors, the shutters that open out to the night sky. Obviously, in this case, it's the afternoon, with the dome around it. Now, the mechanics for this mean that this telescope can actually move in pretty much any direction. It allows 10,000 times more light into the tube than our eyes, and it's designed to look at faint stars. Now, on the other side of this is another smaller telescope, which we call the Finder Viewer. It's a 13-inch refractor. A telescope which uses a lens is called a refractor, and this is used as a viewer finder because you want a wide-angled lens to enable you to look at the night sky before you start to get focused in with the big telescope. Now, what you can't see from this is the actual mount. Now, the mount that the telescope is set on is called an equatorial mount, and this is because the telescope is positioned in such a way that it points towards the North Pole Star. And the reason for this is that these telescopes were used mainly as cameras. So they'd be open with an exposure of anything between 5 and 90 minutes. And during that time, they would have to track the sky, the night sky, following the chosen star as the star, obviously in this case it's the Earth, is moving across the heavens. Now, what was the point of this? Why would we have a telescope with the lens in a large dome here in the middle of the Sussex countryside? Well, this was designed to do 2 things. The first thing was it was designed to look and measure the distance between the Earth and our nearest stars. And the other thing was proper motion. Stars move not just across the night sky for our eyes, but also they move within space at up to about 50,000 miles an hour. Now, this telescope was last used back in 1988, and the system that we use used back in the day was to take 2 photographs. This is called parallax, and you can look it up when you get a moment. Stellar parallax takes 2 photographs where the Earth has moved around the sun to get a fix on the background stars to allow us to measure the distance to the star that we're interested in. So that is the Thomson 26. We'll move on to a slightly different telescope now. So next slide, please. Now you can see this is a completely different design. This is the Yap 36-inch or 91 centimeter reflector. Now this uses a mirror. It was donated by a guy called William Johnston Yap back in 1931, and it was the largest telescope in use at Herstmonceux when this was being used as an observatory. Now it was designed to look at the private lives of stars, and at the end of the telescope it was using 2 mirrors, a large mirror to pick up the light and focus that against a smaller mirror, which you can probably just see right about 3/4 of the way down the telescope in that sort of cage work. Now, what was happening was this was beaming light back into the telescope onto a spectrograph. And a spectrograph takes light from an outside source, in this case a star, and spreads it into tiny rainbows. And what it is doing is looking at how hot a star is. In this case, a blue star is going to be something like 25,000 degrees centigrade, and an orangey red star, which is cooler, is going to be about 4,000 degrees. Now, our sun is an average size star and is about 5,800 degrees on its surface. Inside, though, it's over 15 million degrees where the fusion is taking place. So the spectrograph was looking at a star and using the light pattern was working out how hot it was. Then you have the spectrum of the star, its fingerprint, and this would be mainly hydrogen, but also other types of elements as well. And by looking at the, if you like, the bars from the light, the astronomer was able to work out what the star was made of. The other thing is to measure whether the stars are moving towards us or moving away from us. And this is using something called the Doppler effect, which you've probably heard about. And when a star is traveling towards us, it tends to be bluer. And when a star is moving away from us, it tends to be redder. That's the Doppler effect, and so enables the astronomer to look at these aspects of the night sky. So it gives us understanding. Now, next slide, please. All right, now this, some of you might recognize, has got technology at the heart, and it's the James Webb Space Telescope that was launched on Christmas Day, not last year, but 2 years ago. Now, on NASA's website, you can check out the entire background, excuse me, to this telescope, but it's being seen as the premier observatory, in other words, method of looking at the stars and the universe for the next 10 years. It's got a prime mirror, which has got 18 segments, excuse me. You can see those in the picture, and it gives a fully unfolded diameter of 6.5 meters, so absolutely fulfills what astronomers want in terms of big. The gold you can see is actually ultralight beryllium, because it was designed to be as light as possible. And what you can see folded up on either side is part of a 5-layer sun shield that is about the size, when it was fully unfolded, of a tennis court. Now this was all fitted into a rocket, and you're probably thinking to yourselves, well, how is that possible? Well, it was folded up inside a rocket. It was an Ariadne rocket that was fired up from French Guiana. And while the telescope was flying from its Earth orbit out to its stable orbiting point, which is called a Lagrange point 2 in this case, it's a 1.5 million kilometers away from us. While the telescope was flying, it was unfolding. and it worked absolutely flawlessly. The designers at NASA, with support from other space agencies, really put their hearts and minds into this, and the telescope unfolded. It all worked perfectly, and last year in June it started sending photographs back to Earth. Now, in terms of science for this particular telescope, there are four main themes. The first is, they call it the end of the dark ages. So the infrared vision looks back up to, or can look back up to 13.5 billion years, and showing the first stars and galaxies ever formed. The second was called an assembly of galaxies, and this is looking at the faintest, earliest galaxies up to today's grand spirals and ellipses, and I'm sure you've seen photographs of those. It's also interested in the birth of stars and protoplanetary systems, so it's able to look through dust and gas clouds to find out what is happening behind them, and that's where stars are being born. And then finally, it's looking at planetary systems and the origins of life. So, what is the atmosphere like in extrasolar planets, for example, to see if life is present. So this is an amazing development from an astronomy perspective. And you can see that from the telescopes we've had here at Herstmonceux, which are still functioning to look at the night sky. This is not Herstmonceux, but NASA has moved on into a completely different realm to really enable us to understand the universe. Next slide, please. Tall tales. We're now moving into an area which you'll work out that I like very much, and this is about science fiction. Now, science fiction has got a long history. It goes back at least into Mary Shelley with her book Frankenstein in 1818, and a lot of you will know about Frankenstein, but actually Frankenstein was the name of the doctor and not the monster. Now, before I got involved even with Mary Shelley, The War of the Worlds was a book that really inspired me, and that of course is about an invasion of the Martians, and it was written by H.G. Wells back in 1897, which is when it was serialized. There was also some music made, an album by a guy called Jeff Wayne in 1978, and if you can get a chance to hear it, the voiceover by Richard Burton, a famous actor at the time, is very chilling. I was also inspired by Edgar Rice Burroughs. He's famous for Tarzan, but in this case it was actually Barsoom, his name for Mars, which really got my enthusiasm. And the first book in the series was called A Princess of Mars, and it was written back in 1917. Moving on perhaps into a slightly different sphere, again, an amazing writer, but perhaps known more for his music, is David Bowie. And investigate Ziggy Stardust and the Spiders of Mars, particularly his song Starman back in 1972. Moving a bit up, closer to the present, The Martian by Andy Weir back in 2014 is something that I'm going to be, 2011 is, excuse me, something that I'm going to be looking at in a moment. And many of you know The Martian probably from the fantastic film by Ridley Scott, starring Matt Damon, which was produced back in 2015. So there's an interesting background in science fiction to Mars, and there's a lot more that I can mention, but don't have the time for here. Next slide, please. All right, now then, I've put on screen just a small phrase that really took my attention a couple of weeks ago on the BBC. And it's talking about a professor, Robert Douglas Fairhurst from Magdalen College in Oxford. And he says to his students when they first go up as undergraduates, is that books were lenses that could focus our attention on the world around us, reflect or twist your life into different patterns. Now, what struck me about this was that I see books very much myself as lenses, we've been talking about lenses in the telescopes earlier, and it's interesting, the language of an English professor is very much more akin to perhaps something that a physicist might say. And it struck me that actually he's quite right, that books are a lens. And in the case of science fiction, which does sometimes have a bit of a bad rap as a genre, does point very much to the future. Now, let me give you a definition of science fiction from the Chambers Dictionary. I'll read it out here. So science fiction is a literary genre with speculative and technological developments, especially the imaginative presentation, often set in the future, of people and environments on the Earth, on other planets, or in space. Informally, it says science fiction. Now, I might mention a couple of films, but actually I really want to focus on science fiction and the actual science fiction. But before I go into the two books that the two areas that I'd like to talk about, the next slide is quite interesting for a variety of points. The next slide, please, Sophie. Imagination. Now, you can see there on the slide, it's a photograph of a picture that was first published back in 1939, and it shows the man from Mars. It was drawn by Frank R. Paul for the magazine called Fantastic Adventures. Now, this particular picture has always enthralled me because it shows an astronaut, presumably from the Earth, shaking hands with a Martian. Now, as you'll see from my next slide, we're not quite there yet. The way that we often see Mars, whether it's from H.G. Wells with The War of the Worlds, or with some other aspects of science fiction and Mars, it's conflict. We're fighting for survival against an external enemy. In this case, we're actually greeting an external extraterrestrial person or Martian as a friend. And there are two schools of thought on this. An astronomer who worked here, Patrick Moore, was very much in favour of broadcasting our presence into the universe and felt that was an absolutely positive thing. He could not imagine that there would be hostile lives out there. On the other side of the fence was Stephen Hawking, and he felt that we should keep absolutely dead quiet and not promote the fact that we existed. I think I probably lean a little bit more towards Patrick Moore, and that's not because he worked here with the Thompson telescope. Now, the other thing about imagination is that science fiction has got itself a huge variety of genres, dealing with catastrophes, spaceships, distant planets, alien life, future cities, great machines, robots, and space-going cities. And that was a list actually put together by a science fiction writer called Brian Aldiss, who edited the book from which this picture comes, Science Fiction in Art, back in 1975. So next slide, please, Sophie. Mars attacks, pulp fiction. Now, these days we have science fiction for adults, for young adults, and even for children. John Willis, Tony Ross, with their Dr. Zargle's book of Earthhounds, and also humour from The Hitchhiker's Guide to the Galaxy. Now, my first real encounter with science fiction was a series of 55 cards. They were cards you could buy and swap, called Mars Attacks. Now, this was back in 1962. So as I say, I was very small, but absolutely thrilled by these cards detailing the invasion from the Martians, as you can see, pretty terrifying, entering the Earth and destroying as much as they possibly could. Now, the cards and the series was eventually stopped because there was something of an outcry against what was seen as graphic violence and titillation that was coming from this particular type of science fiction. But in a way, it also leans back into science fiction at the beginning of the last century, which was very much seen as pulp fiction. It was titillating, it was graphic, it was perhaps more violent. We saw the world in us and them, very much in very bright colours. So perhaps not the kind of thing that you would give to a 6-year-old child. Having said that, I really loved it. But it may be something that you perhaps shouldn't go to have a look at. Now, the other thing to bear in mind with imagination and Mars attacks is thinking about my next slide, which I'll talk about in a moment, is that very often we have scientists themselves as authors. Now, the next author is not a scientist, but he gets the science pretty much right. So next slide, please, Sophie. Now, this is The Martian by Andy Weir, and it's about creativity. Now, this book is creative in a variety of levels. One particularly is about the publishing, because Andy Weir published the book online and got information and ideas from his readership on how the novel should actually move on. Now, science fiction has really come, I think, of kind of age with a book like this, because the content and the science is pretty much spot on, except for one aspect. Now, there are other scientists who've also become involved in science fiction. Some of the names might be familiar to you, some certainly not. Fred Hoyle, he was an astronomer. C.P. Snow was a scientist and also civil servant. Isaac Asimov, one of the greats of science as well as science fiction. We've got Stephen Baxter, more modern, and Jim Al-Khalili, who also is a pundit, not a pundit, a scientist on television and on radio, but he's also written science fiction. So there are serious people behind this. And the other thing which is interesting about this particular book, The Martian, is that NASA were one of the sponsors for the film The Martian, which I mentioned earlier, that came out in 2015. And they were so enamored by Andy Weir's book that they put their shoulder to that particular wheel. There is, though, something that is incorrect as far as the Martian story is concerned. And I'll leave that hanging for you perhaps to find out. So next slide, please, Sophie. But I didn't come here just to talk about science fiction. I want to talk about true stories. Now, in terms of true stories, I'm talking about working here at the Observatory Science Centre, where we are looking at, on the one hand, edutainment. We have a lot of school groups that come through, very small ones. We had a lot in today. We have foreign student groups coming in to look at science, and they all go away having had not just a wonderful time, but also real hands-on experience of science. Now, for the science to work, of course, it has to be right. It has to be true. And I'm moving now from science fiction, which of course is a fiction, it's a made-up story, into the real world of science. Next slide, Sophie. Thank you. Now there you have a view of the Observatory Science Centre, and the domes you can see in front of you, those are where the telescopes are kept. The one to the left has actually got the astrographic. The dome with the Thomson telescope I mentioned earlier is just out of view on the left. And then in the middle, behind what looks like a framework, that's actually a tent in summer, you can see the dome where the Yap telescope is kept. Now, we open the domes, certainly dome with the Yap telescope and the one for the Thomson telescope, during the year, so people can get absolute access to them. And we have, again, this photograph coming up of Dome F, which is just out of picture here, which has another type of telescope inside it, and also more information. But this is where the inspiration comes from. When people come into this place, they're perhaps a little overawed by the nature of the building, which is a grade 2 listed building, but they go away, I think, with a smile on their faces and inspired in some way. Sophie, please. Okay, so we have discovery. That's one aspect that we have here, and this is an interactive display which shows the solar system with Mars and other planets. And you can simply press a screen and get the planets to roll in front of you. And this, obviously I'm talking about Mars, is one with a lot of information about the planet Mars. So Sophie, next slide. Critical thinking. This in a way is perhaps part of the core aspect. Now this is the Hargreaves Schmidt Congo telescope taken up from the gantry behind it. The gantry is used to, if you like, remove the lens cap, excuse me, and also to get to maintenance on the telescope. This telescope, though, was never used. It was designed for use in the Congo, but due to payment problems, it never went out to the Congo, and it was bought for use here in Herstmonceux. But there was a fault in the mirror. The mirrors here are usually glass, sometimes ceramic background, but it's the face that is really important. In the case of this particular telescope, there was a flaw, so it couldn't be used. But what you can see, perhaps not very clearly, behind and below it are display cases as well as information sheets on the back wall showing how telescopes are put together and how they work. And it's about science, it's about critical thinking. If you're looking at literature, if you're looking at poetry, you need critical thinking. If you're looking at science, you also need critical thinking. You need to question, you need to be agnostic in what you're looking at and prove that what you think should be, well, you can't prove what should be right, but you need to prove that what you're looking at is scientifically correct. And I think sometimes in our world at the moment, we have too much non-critical thinking going on. So if it's something I would like to pass on to you, is hone your critical thinking. It will help us and help you in developing your careers. Now, one thing we don't train in critical thinking here, but you can't help but become part of that. We have a whole variety of people that work on site here, from our well-educated scientific experts, PhDs, master's degrees in astrophysics, down to people with life experience from working as electricians or as tool makers. And if you fancy the idea of working at the observatory during the summer, perhaps at weekends, if you're not too far away, then make contact with us. And let's go for the last slide then, Sophie. Spectacular science. What we offer here is spectacular. And there is a slight pun there because I've been talking about lenses, but it's also a lens that not only helps us look through to the night sky, a lens through science fiction that enable us to look at the human condition and what it's like to be living in space, but also a lens on ourselves. We can then look back, how do we stack up in the way we do things? And if you're fresh from school, this is a perfect place to hone transferable skills for the business world. And one thing to mention is that if you go onto the NASA website, we'll come onto that in just a moment, there are lots of posters saying, come and work on Mars, be a surveyor, be a teacher, come and get your skills. So they're already thinking about manned missions to Mars, through the Artemis 1 on the moon at the moment, and then forwards. Ditto with the British government. They're saying that over the next 10 years, there are going to be something like 30,000 jobs in the space industry in this country. So if you are in any way interested in space, whether from a science fiction aspect, as I was, or from a science background, there's a very bright future ahead for you. So finally, the last slide, Sophie. Here I've headed up some websites that are worth having a look at. Our observatory at the top. There's the British Science Fiction Association, the James Webb Space Telescope for NASA, UK Government Space Agency, and also the European Space Agency. And then finally a book which talks about space being open for business. That's well worth having a look at. I think we've got a few minutes left. I will stop talking at this juncture. I hope I've made some points that interest you. So let's see how much I have through the questions.
Thank you very much, Ivor, and to Sophie there. Yes, it really was an informative and interesting talk, and we hope our audience has been inspired, and maybe they can visit the observatory at some point if they haven't done so already. So, as I've said, lots of interesting questions coming in, so I'll hand you over back to Sophie again to put those to you.
All right, thank you very much.
Thank you, Lisa. Okay, so the first question I've got, so perhaps I can talk a little bit more about this, is how can I volunteer at the Observatory Science Centre?
Okay, well, the easiest thing to do is simply to go onto our website, and make contact with us. You can do that through the site, and we will then, if you sound promising, make contact with you, invite you around for an interview, and if you're one of the lucky ones, and you have to be very lucky to work here, we'll take you on.
Fantastic. Okay. So what university degrees are good for working at the observatory?
Well, I mean, I think you probably realise that I'm not a scientist by training, so I've actually got an English degree and a master's in comparative literary studies. It's more of I think the attitude that's important. We also have people here who've got physics degrees. One of my colleagues has a freshly minted physics degree. We've also got somebody with a master's degree in astrophysics, but we don't necessarily need somebody in that area. That's fantastic to have. I think if your background, if you've got a degree, or even if you're working on your A-levels, we'd love to see you, because it's your attitude, the kind of skills you have, the way you interact with people that come here to improve their experience, which you can then take with you when you move on into your own career later on.
Okay, that's great. So just leading on from that question, what subject should I study if I wanted to work in astronomy?
Well, I think it's the classic. In a way, you're asking the wrong person, because I'm of course very biased. I would say that you would need to study maths, physics, chemistry, and literature, but that's probably not possible. Too much of a hit. But it is maths, physics, chemistry, perhaps biology, the classic kind of STEM background. Maybe also some technology, design work, or economics. Again, depending on where your kind of interest lies, but certainly a mix of STEM subjects would be useful. And if you could, hopefully, I hope through my enthusiasm, perhaps pick up on science fiction in your spare time, all to the better.
Fantastic. Do you think we will find more planets in the future?
Oh, they're finding planets all the time. I mean, in terms of exoplanets, I think the latest score from NASA is 3,200. So they're looking all the time. And as I mentioned earlier, the James Webb Space Telescope is set up to look out for planets that could support life, you know, the Goldilocks planets. And I'm pretty sure they're going to find loads more.
It does sound that way, doesn't it?
Yes, absolutely.
Fantastic. Have you always worked at the observatory?
No, I haven't. My background is actually in, excuse me, literature, languages, and business. So I've got a business background, actually looking at ethics and values. So there is also an interesting area there about space ethics or astroethics, and how we are working and how we want to work in space. Sustainability is also an area that I'm interested in, not just here at the observatory, but also in general terms, and space junk. If we can find a way of getting rid of space junk, if any of you out there can find a way of getting rid of space junk, then you will earn yourselves loads of money, if that's what you want, and do the human race a huge well, make a huge benefit to the human race.
Thank you. That's really interesting. So many different areas and paths and ways of getting into things, aren't there? It's really good.
Absolutely.
Okay. So have you seen any new stars yourself?
I wouldn't say I've seen any new stars. I mean, given that I don't have a background in astronomy, every time I see a star, it's kind of new. So in that respect, being able to work here, and we have our stargazing evenings during the winter and or late autumn, winter and spring months, where we have the telescopes working. So I get the opportunity occasionally to put my eye against the viewfinder and look up at space. And seeing something like the Pleiades or the nebula just underneath Orion's belt, fantastic. It's absolutely, well, I find it quite emotional. I know that sounds a strange thing to say from a science centre, but you do get a sense of, space is big and space is great.
Okay, fantastic. So I think that also answers the question of what's the best thing you've seen?
Oh, I think the best thing I've seen was probably Saturn. I mean, you know my link and my enthusiasm for science fiction, but it showed Saturn on its side with the rings. It was black and white, and you could see through the rings, you could see Saturn, and it just looked absolutely fantastic. And I thought, there it is. It's up there in the sky. It's not just a picture. It's real. It's actual. Loved it.
Fantastic. Can you visit the Science Observatory?
Sorry, can we visit? Well,
yeah. How can people visit if they wanted to visit?
Okay, well, we're a little bit in the country, but there are two best ways of getting here. One way is by car, of course. The other is then either through a school trip, when you come together as part of a party, or if you're being very much intrepid, every Wednesday there's a bus called the Cuckmere Express that comes up from Eastbourne that brings the bus up to here at the centre. So those are the ways to come in. We're open pretty much 7 days a week. We're only really closed over the very cold month of sort of December, early January. Otherwise, we're open the whole time. Just give us a call and find out when there's availability. Oh,
that's great. So you can just kind of book and come along. Absolutely. At any time. Fantastic. Okay. Let me see what else. We've got quite a few come through. Have you ever met someone who's been to space?
The only thing I've met that's been to space is a tile that we have in one of our shows, and we use it to show a heat experiment. They're the black tiles that would be along, say, the leading edge of the shuttle. In fact, it was the Buran spacecraft. But we have an unused tile which is black and absolutely perfect, and then there's one that has had the edges worn off and the outer coating's gone. And that has come from space. It's from the Russian Buran. So that's probably the closest I've been to space, except for some of the other exhibits. We've got a meteorite exhibit in the centre, and I go and touch that occasionally, just to remind myself that space is out there.
Fantastic. I've got a question here. How do the telescopes see into the future and the past?
How do they see into the future and the past? Well, the thing about looking in the past, in fact, we look at the past every day, because it takes 8 minutes from the rays of the sun and the warmth of the sun to reach us on Earth. So when we're looking at the sun, we're actually looking at it as it was 8 minutes earlier. So this is where you start to get a bit crazy. So we're looking back into the past, and then with the telescope, like the James Webb Space Telescope, because of the way it looks back far into the light coming out of ancient galaxies, this light, of course, is coming back to us. There's one photograph, they call it the, what was the name of the photograph? It was in June last year, and it was looking back to galaxies showing light from 4.62 billion years ago. So halfway back to the beginning of the universe. This is something that have to sit down and think about a bit. When you're looking at light coming from stars, it's light that was produced billions of years ago. So we are looking back into the history of those stars. We can look sometimes into the future. I mean, there's a conversation at the moment about Betelgeuse. That's the big red star in Orion's left arm, Orion the Hunter. And there's often thought that because it's a red giant, that maybe Betelgeuse has already turned into a supernova. But we won't know. It might happen any time. It might have happened a while ago. We're still waiting for the light to come to us. So, in a way, we're looking a little bit into the past again there, and looking into the future. That's perhaps a bit more difficult. When you're looking and observing the telescope, you're looking more into the past and more into the present. Looking into the future, that would be something quite interesting. And I suppose that's where science fiction comes in, because the imagination of science fiction writers is where that aspect of science is looked at.
Yes, all theories, isn't it, that into the future, or yes, what could happen. So exactly. I've got a couple of quick questions. How old do you have to be to work at the observatory?
You have to be a minimum age of 16.
Okay. How long have you been working at the observatory for?
I've only been here for 18 months, so I'm a newbie.
Okay. What is the next goal for space scientists after Mars?
The next goal for space scientists after Mars? Crikey. I think I'd have to point you towards the NASA website, actually, and go and explore that, because that's where this kind of ideas are coming through. Off the top of my head, I can't think of what the next planet is looking at. I mean, as we discussed earlier, they're looking for exoplanets. in terms of what we do in our own solar system, that's a very good question. I think all the planets are interesting, certainly the gas and the ice giants. And the book I mentioned by Jacobson, in terms of using minerals and using materials from space, is going to be a way forward. But we're also thinking there that maybe we should only be using 8% of anything, whether it's an asteroid or another planet, rather than end up destroying items that we find so beautiful. I mean, it'd be tragic, wouldn't it, to mine the moon in such a way the moon then disappears, or begins to affect our tides, or not affect our tides. So this is something we have to be very careful with. But to answer the question directly, I can't think off the top of my head what the next most important one to look at. But as I say, go and look at the NASA website, because that will give you some indications.
That's really interesting. Yes, definitely. No, you wouldn't ever think, would you, that doing something to the moon, how that could affect us back down here on Earth, would you? But clearly
absolutely.
It can.
There are lots of interesting items. I mean, the moon was originally part of the Earth, so there's oxygen on the moon. We're always talking as well about ice on Mars and life on Mars. This is why it's been so fascinating over the years. So we have to be very careful about what we and how we go about things for the future. The other thing is, and this is also what the book I mentioned goes on to talk about, is that really we should try and look at our own home planet as being the home planet, and try and maintain the biodiversity and the beauty that we have on this planet, because it is absolutely rare. Try and look after that, and any heavy industries that we might think for the future of the space race should be done in space. And there's some very interesting thought about the fact you can build bigger and lighter in space because there's no gravity.
Interesting.
Gravity,
okay, and what's your advice on becoming a space scientist?
Advice on becoming a space scientist? I think the first thing is enthusiasm. Find an area that you really like. Whatever that might be. It could be something in medicine, perhaps. It could be in gastronomy, food for scientists. It could be, the nuts and bolts of engineering. Have a look around. Try and find people who come and talk to us here at the observatory. Talk to my colleagues and the kind of backgrounds that they have. Find something you're really passionate about and follow it, because that, as anybody knows who studied, that's what drives you forward. And then when you want to find work, if you've got enthusiasm and passion, that also spreads itself to the person that's interested in employing you. Goes a long way. Okay,
so I've got two more fairly quick questions. I think then we'll have to wrap it up there. So the first one is, what's your favourite telescope?
Oh, it has to be the Thompson here in Dome E. I just love it. There's something, it's just such fantastic, over-engineered Victorian work. It's just absolutely brilliant. And although I've never seen it up close, of course, it's now 1.5 million kilometres away, but the James Webb Space Telescope is pretty special too.
Fantastic. And are there sun UV filters on the telescopes? I'm assuming that they mean the ones down at your observatory, or?
Well, no, because if you anything to do with the sun, you need a solar scope. So, and these are special telescopes designed for looking at the sun, and they've got a completely different design. So we don't need UV filters on the telescopes that we use here. In fact, it would be dangerous to point those at the sun for a variety of reasons. But come along and talk to us, and we'll explain to you why that's the case.
Okay, thank you so much for that, Ivor, and answering those questions. Really, really fascinating, and so much enthusiasm for this subject. I'm just going to hand you over to Lisa now, who's just going to finish off. Thank you.
Thank you, Sophie. Thank you very much, Sophie, and to Ivor. It sure is interesting, and I'm sure we could go well into the afternoon discussing all the things that are up in space, or maybe not up in space. But thanks again, very, very interesting. We have been hosting live talks every day this week to celebrate Mars and National Careers Weeks. So do take a look at our website. It should be in the chat, and hopefully you can join us for another talk similar to Ivor. So we'll also be hosting talks next week because we have British Science Week coming up, which no doubt will feature much more space. So thank you to everyone who joined us today. Enjoy the rest of Mars Week, and thank you very much, Ivor. Goodbye, everyone.
Cheerio. Bye-bye.